Welcome back, everybody. This video we'll be talking about problem solving with equations. Some of the problems will be just setting up the equations, and then some of them will actually be setting up and solving. Let's get started. First one here, Tammy is 36 years old. Tammy's age is 3 years older than 2 times Jim's age. Let J represent Jim's age. Which equation can be used to solve for Jim's age? All right. So Tammy is 36 years old. You can say 36 for Tammy. And then we say Tammy's age is 3 years older, so we will be 3 years more than 2 times Jim's age. 3 years more, 3 plus, and then 2J for 2 times Jim's age. As we can see here, B is the right choice. Notice the 3 and the 2J were just flipped around. That doesn't matter. The commutative property of addition says we can do that. B is the best one to fit here. We don't actually have to solve it. If we did, we would just simply subtract 3 and divide by 2. Alright, let's look at another one here. The sum of 3 consecutive integers is 24. Let x represent the first integer, x plus 2 represent the second, and x plus 4 represent the third. What is the equation that can be used to find the integer? So again, we're just setting this up. So we got 3 unknown integers that are consecutive and even. So think of the numbers 2, 4, 6, 8, 10, 12, 14, and so on. The first one we're going to call x. The next one we're going to call x plus 2. The third one we'll call x plus 4. Just like they say in the problem up above, and it adds up to 24. Now it says the sum, we see the word sum. Each of these expressions for the 3 integers are going to be a plus sign in between x, so it's really saying x plus 2 plus x plus 4. And now we're just going to simplify the equation. Notice we have 1, 2, 3 x's. And we have 2 and 4 to make 6. And it adds up to 24. And you know this is going to match choice A. Now if we actually were to find those 3 integers, we would solve this equation. That would tell us what the first integer is. Then we just find the other 2 by adding 2 in succession after that. But yeah, this one's just about setting up again. Alright, let's do one where we actually set up the equation and then we need to solve it. It says there's $3.90 worth of nickels and quarters in a piggy bank. 6 more quarters than nickels. How many of each coin are there in the bank? Okay, well let's set up first some variables. We have N for nickels, number of nickels, and why don't we have Q for the number of quarters. And we can make an equation based on this, but next to each variable we're going to multiply its worth. So a nickel is worth 5 cents, 0.05 N. Adding to that the quarter we know is 0.25 Q. And together, those add up to $3.90, 3.90. Now, you can't solve one equation with 2 different variables. We're going to use a little bit of substitution to just eliminate it down to 1 variable. Now, it does say there are 6 more quarters than nickels, okay? So, the number of quarters we could say equals the number of nickels plus 6 more, if that makes sense. The number of quarters is N plus 6. So every time we see a Q, we can write the expression N plus 6. Let's rewrite our equation here. Simplify it down a little bit. 0.05 plus 0.25 Q, but I'm not going to write Q this time. Instead of saying 3.90, I'm just going to say 3.9. I'm going to use the expression N plus 6. Because I know there are 6 more quarters than nickel. There are 6 more quarters than nickels. The N plus 6 expression represents my Q quarters. And now I'm going to solve this equation for N 0.5 n plus 0.25 n. Use the distributive property here to solve. And then I need to take 0.25 times 6 and I get 1.5. Still equal to 3.9. Alright, I'm going to combine like terms. I'm going to combine the 0.05 and the 0.25 to get 0.3 n. I'm going to take away 1.5 from both sides, get all the numbers to the other side as we're working here. And then 3 minus 1 is 2, 9 minus 5, 4. 0.3 n equals 2.4. I'm going to divide both sides by 0.3 n. Or just 0.3 rather. 2.4 divided by 0.3 is 8. N equals 8. That tells me the number of nickels. There are 8 nickels. And then to find the number of quarters, I'll just put an 8 in for n here. Over here, this other equation we made, number of quarters is 8 plus 6. 8 plus 6 equals 14. There are 14 quarters, Q for quarters, and there are 8 nickels. Alright, let's look at another one here. It says a rectangle has a width of 7.9 feet and a perimeter of 27.2 feet. What's the length of the rectangle? Okay, well, think of a rectangle. This is length of width and a length and a width. And apparently we don't know L, the length, but we do know width. They tell us the width is 7.9. Now to find the perimeter, all you need to do is add up all the widths, there are 2 of them, and all the lengths, of which there are 2 of those. And then we're going to go back to this. Notice I wrote it with 3 different variables, P, W, and L, but I know 2 of the 3. I know the perimeter to be 27.2. I know the width to be 7.9. But I don't know L. So I'm just going to keep that L and L. Alright, let's simplify this. If I have L and L, that means I have 2 L's. 7.9 plus 7.9. Calculator says 15.8. Just combining like terms, simplifying the equation. Next thing I'm going to do is notice what happening to L. L's are variable. It's being multiplied by 2, and we're also adding the 15.8. So I want to do the opposite of add 15.8. I want to subtract 15.8. And to keep the equation balanced, I need to do that to both sides, minus 15.8 on both sides. 27.2 minus 15.8. Alright, we're going to get 11.4. And then to find L, we divide by 2. 11.4 divided by 2. 5.7. The length of the rectangle. 5.7 feet. Alright, last one. Train A and Train B leave a central station at the same time. They travel at the same speed but in opposite directions. Train A heading toward the station A and Train B heading toward station B. Train A reaches the station after 2.5 hours. Train B reaches the station after 4.5 hours. Station A and Station B are 585 miles apart. What's the rate of the trains? How fast were they going, basically? Well, let me start off by writing this equation. D equals RT. And D equals RT is distance equals rate times time. And we have that situation here, but it's a little bit more complicated. So here's kind of a visual of what's happening here. Alright, let's say here's Station A, here's Station B. And they do tell us that they are 585 miles apart. So we got 2 trains going in opposite directions. They're both going the same speed. Here's Train A. We'll say this represents Train A, this represents Train B. And this to travel whatever distance it travels, we know that train A took 2.5 hours to get to their station, but train B took 4 hours. Train B was definitely going slower. Alright, does it make sense if distance equals rate times time? Let's say train A, let's kind of think about rate times time for train A, if I can get this drawn right. And then also train B. Train A goes a certain distance, train B goes a certain distance. Those distances can be calculated by train A's rate times time. For the distance of train B could also be calculated by its rate times time. And doesn't it make sense that they both are going to add up to that total distance? Rate times time of train A plus the rate times time of train B will add up to the total distance of 585. So remember the formula, rate distance equals rate times time. They're both going to add up to make 585 miles. We don't know train A's rate, we'll keep that R, but we do know how long it took. It took 2.5. I'm just going to say 2.5. Rate of train B is the same as the rate of train A, that's why we use the same R, but it took 4 hours to get there. Alright, now it's just a simple equation that we can solve. 2.5R, 4R, comes together like terms, we can add those together to get 6.5R equal to 585. To solve for R, we can divide both sides by 6.5. And if you take 585 and divide it by 6.5, guess what? We get 90 miles an hour. Both trains were going 90 mph. Alright, and there's several examples involving story problems and problem solving with equations. I hope this helped. Thank you very much for watching.